Hello, everyone. Welcome to the class of Building Construction Organization and Management. In this class, we will study the optimization of network schedule. When preparing a network schedule for a construction project, it is generally not feasible to create a fully optimized schedule in one attempt. The critical path in the initial network schedule is often excessively long, while non-critical paths have a large amount of float time, making the network loose and the project activity duration long. Typically, after the initial network schedule is formulated, adjustments and optimization are needed based on the characteristics of the project activities. Time, cost, and labor should be matched appropriately in terms of the construction project. To achieve the optimal project duration, the lowest cost, and the most efficient use of resources, network schedule optimization refers to the process of balancing the relationship between time, resources, and cost, using float time under certain constraints. It seeks a network schedule with the shortest duration, lowest cost, and most efficient resource utilization. The optimization objectives of network schedule should be determined according to the requirements and constraints of the project activity. These include project duration objectives, cost objectives, and resource objectives. Depending on the different optimization objectives, network schedule optimization can be categorized into which of time, cost, and resource. Cost optimization is also referred to as time-cost optimization, referred to seek the optimal project duration for the minimum cost with the corresponding schedule. Alternatively, it may refer to seeking the lowest cost using shortest project duration and developing the corresponding schedule. Resource optimization refers to adjusting the start times of activities so that the resource distribution over time aligns with the optimization objectives. It includes two types: time optimization under limited resources and resource leveling under fixed project duration. Today, we will focus on time optimization. Time optimization is used to achieve the target project duration by compressing the calculated duration when the calculated project duration does not meet the required duration, or to minimize the total project duration under certain constraints. The basic method of time optimization for network schedule is to compress the duration of critical activities without changing the logical relationships between activities in the network. In the time optimization process, we must follow the principle of economic rationality. Critical activities should not be compressed to non-critical ones. Additionally, during the optimization process, if multiple critical paths emerge, the total duration of each critical path must be compressed to the same amount. Otherwise, the project duration cannot be effectively reduced. This method is not difficult to understand. Critical activities determine the overall project duration. To solve complex problems effectively, we must identify and focus on the main contradiction. It is like finding the pressure point in a system, and a precise move can shift the whole outcome. Compressing the durations of critical activities on the critical path can effectively shorten the overall project duration. The steps for time optimization are as follows. Step 1. Calculate the project duration first and identify the critical path and critical activities. Step 2. Based on the required duration, calculate the time reduction target delta T, which is the difference between the calculated and required time duration. Step 3. Select the critical activities whose duration should be shortened. When choosing the activities to be compressed, consider the following factors. First, activities whose duration can be shortened with minimal impact on quality and safety. Second, activities with sufficient backup resources available. Third, activities for which the additional cost of shortening is minimal. Step 4. Compress the prioritized critical activities to their minimum possible duration and identify the new critical path. If the compressed activity becomes non-critical, its duration should be extended. To deliberately make it a critical activity again. Step 5. If the calculated project duration still exceeds the required duration, repeat the above steps until the required duration is met, or until the duration can no longer be reduced. Step 6. When all critical activities have been compressed to their minimum limits, and no further duration reduction is feasible, while the calculated project duration still does not meet the required duration, we must adjust the original technical or organizational schedule, or reassess the required duration. The following principles should be followed in time optimization. First, compress critical activities to shorten the project duration. Second, the selection of critical activities for compression should follow these rules. After compression, the critical activity should still remain critical. If multiple critical paths exist, compression must be carried out simultaneously and synchronously. Now, let's look at a case study. A network diagram is shown as follows. The data in parentheses represent the minimum possible duration of activities. Assume the required project duration is 100 days. Try optimizing the project duration. Step 1. Use normal activity duration to calculate the earliest and latest times of activity nodes, and identify the critical activities and critical path, as shown in the diagram. The critical path is marked by bold arrows. The path of node 1 to node 3 to node 4 to node 6. The critical activities are activity 1 to 3, activity 3 to 4, and activity 4 to 6. Step 2. Calculate the required reduction in duration. Based on the calculated project duration in the diagram, the duration needs to be shortened by 60 days. According to the data in the original diagram, activity 1 to 3 can be shortened by 20 days, activity 3 to 4 by 30 days, and activity 4 to 6 by 25 days. A total potential reduction of 75 days. However, based on the principles mentioned earlier, shortening activity 4 to 6 requires significantly more labors. Therefore, only 10 days are reduced from it. The network is recalculated and shown in the diagram. The critical path is the path of node 1 to node 2 to node 3 to node 5 to node 6. The critical activities are activity 1 to 2, activity 2 to 3, activity 3 to 5, and activity 5 to 6. The project duration is now 120 days. According to the management's requirement, the project duration still needs to be reduced by 20 days. Based on previously stated principles, time reduction in activity 2 to 3 and activity 3 to 5 is more suitable. Replace the normal duration of activity 2 to 3 and activity 3 to 5 with their minimum duration. Recalculate the network schedule parameters as shown in the diagram. The critical path now goes through node 1, node 3, node 4 and node 6. The duration is 100 days, which meets the requirement. Well, today we mainly studied the meaning and significance of network schedule optimization, focusing on the method of time optimization and the critical activity compression method. I hope you can use this flexibly in your future studies and apply it comprehensively. That's all for today. See you next class.